I'm going to make this into, my first step is make this into an augmented matrix. 3, 2, 1, -4, -4, 2, 6, -5, -3, and 10, -14, 0. That's my first step. Now the next thing that I'm going to do, I want that first thing to be 1. So I'm going to switch 1 and 3 so that I can make this 1, 2, -3, 0. I'm going to keep this one the same. And the last row, first row became the last row. So that's all I did. So now that this is a 1, now I need to make these two guys equal to 0. So I want to multiply the top by -2 and add. So -2, I'm going to use a different color here for you guys. See this a little better. So -2, 2 times -2 is -4. And -3 times -2 is +6. Okay, so let's see what happens when we do this. Oh, I'm sorry, 0 times -2 is still 0. Okay, let's add this to the second, and let's see what happens. So we keep the first row the same. You don't want to change that. So -2 plus 2 is 0. -4 plus -4 is -8. 6 plus -5 is 1. 0 plus -14 is -14. Okay, so now let's change this to the 3. So we want to multiply everything by -3. -3, 2 times -3 is -6. -3 times -3 is +9. And this one is still 0. So let's do those. -3 plus 3 is 0. -6 minus 4 is -10. 9 plus 6 is 15. 0 plus 10 is 10. Okay, so now looking at this, we want to do a couple of things. We need to make this guy now equal to 1. So let's divide everything by -8. 1, 2, -3, 0, 0, 1, -1/8. We have 14/8, which is also 7/4. And then 0, -10, 15, 10. Okay. Now, do you see anything, before I write the last one down, do you see anything we could do with this? Could I divide these by 5, this row? So let's divide this row by 5, just to get easier numbers. -2, 3, 2. Okay, I just made my numbers easier. So I divided the second row by -8, and I divided this row by 5. I didn't care about doing it by -5. So now, in order to get this 1, to get this guy to be 0, so I have to multiply this row by 2. So 0, 1 times 2 is 2. -1/8 times 2 is -1/4. 7/4 times 2 is 7/2. And add it to the next row. So this stays the same. This stays the same. 0 plus 0 is 0. Doesn't affect that. 2 plus -2 is 0. 3 minus 1/4 is, let's see, 3, how many quarters is that? 12 minus 1 is 11 quarters. And 12 plus 7/2, or 2 plus 7/2, so 4/2 plus 7/2 is 11/2. So now we need to make this a 1. So in order to make this a 1, I need to multiply everything by 4/11ths. Times 4/11ths times 4/11ths. Well, this is going to come out nice. Okay. So keep the first the same. Keep the second one the same. The third one becomes 0, 0, 1. The 11s cancel. 4 divided by 2 is 2. Okay, so now I don't want to stop because I want to make these two. Now I want to start working up. So exactly the same thing I did here going down. Now I want to use 3 to go up and get these two. These zeros won't even affect anything. So this is actually a little bit easier. So how would I make that? What would I have to add that to get this one to be 0? I hope you say 1/8 in your head. So 1 times 1/8, 2 times 1/8 is 1/4. So let's add these two. Oops, wrong color. Blue. All right. So I'm going to keep the bottom row now the same, because we're working from the bottom up now. So 0 plus 0 is still 0. 0 plus 1 is still 1. 1/8 minus 1/8 is 0. 1/4 plus 7/4 is 8/4, and 8/4 is 2. Now what about this one? I want to make this guy into a 0 now also. So I need to multiply by 3. So 1 times 3, 2 times 3. So we have 3 plus 3. Let's leave these the same. They won't change. 3 plus negative 3 is 0. 6 plus 0 is 6. Okay, one more step. Now, I'm going to use the middle one to fix this and make this into 0. So I need to multiply this row by negative 2. Nothing changes except for those two. Oops. It becomes negative 4. And what happens to this? We have 0, nothing changes there. In fact, the bottom one doesn't change. The second one doesn't change. The top's the only thing that's going to change. This first one's not going to change. 2 minus 2 is 0. 0 plus 0 is 0. 6 minus 4 is 2. And now we have a very easy answer. So x equals 2. Y equals 2. And z equals 2. Wow, everything is 2. And that's our ordered pair. We have a unique solution. Okay, so if you look at this at the top, we can make sure that we're right. So 3 times 2 is 6 minus 8 plus 12. Is that 10? Yes. This would be 4 minus 8 minus 10. Is that negative 14? Yes. So this is 2 plus 4 minus 6. Is that 0? Yes. So we checked our answer even, and it's just right. All right, so let's talk about using your calculator. So when we go to use the calculator, you guys know how to put a matrix in now. So we're going to go second matrix. Oops, I do that. It happens every time, doesn't it? Second matrix. Come on. And we're going to go to edit our matrix. I'm going to edit matrix A. So I'm going to put the augmented matrix in. So I have actually 3 rows and 4 columns. So now I'm going to enter the augmented matrix. I'm going to use this one we had. 3, negative 4, 6, 10, 2, negative 4, negative 5, and negative 14. In the bottom, 1, 2, negative 3, and 0. That's the same. Okay, so let me quit out of this. Now, once I have that entered, I'm going to hit matrix. I'm going to arrow over to math. Now, I can use REF, so scroll down here, you'll see them. I can either use REF or RREF. The REF will give me row echelon form. Let's just look at that real quick. And this was matrix A, so I'm going to click that. I'm going to call matrix A back up. So second, x negative 1, matrix A. So this is, I want to make that into fractions. I can't see that. Math to fraction. There we go. That should work. Okay. So I've made that into a fraction. Now, you think to yourself, wait a minute. That's not the same one that I got. So let's look up here. When we were at the row echelon form, which was actually this one, we have a different answer. However, we still have the same at the bottom. X or Z was equal to 2. The reason that it's different answers is because the calculator did not switch the rows. The calculator divided the first row by 3, as you can see as negative 4/3 and 10/3. So it went from there. If it had switched the rows, we would have the same answer. But since we didn't, we can possibly get different answers for the row echelon form. And there's still the equivalent system. Now, I can also hit, oops, not alpha, second matrix, go to math. If I use RREF, which is reduced row echelon form, that's what RREF stands for. Let me move this up here for you guys. Okay. Now, if I put in matrix A, pull up matrix A, watch what happens. I get the reduced row echelon form, which was the identity matrix over here, and everything was 2. And it's very, very easy for me to put that. Now you notice I put this extra hint in here, which I actually did, which was if your answers are not whole numbers, you can hit the math and enter, and it will convert everything to fractions so that when you write it down, it's a little cleaner. Okay, so let's talk about 4 equations and 4 variables. How would we do this? So the first thing we need to do is we need to do an augmented matrix. 1, negative 1, 2, 1, 3, 3, negative 2, negative 1, negative 1, 4, 2, 1, 2, negative 1, 10, 1, 2, 1, negative 3, 8. Okay, now my first one is 1. I would have to make all 3 of these equal to 0. Or I can even make this a little bit easier. I can actually say, wait a second, why don't I do this? Second matrix. I'm just going to edit my 3 by 4 a little bit more and make that now 4 by 5. All right, 1, negative 1. You can pause the video and put this in your... Okay, so once your matrix is in, we're going to go to... Actually, I like to quit out of this. So go back to matrices, go to math, go down to reduced row echelon form, which is also alpha. It's B, so it's alpha apps if you really want to do that. And I'm going to put in matrix A again. Hit enter. There it is. So I go RREF of A, and then that equals 3, 2, 1, 0. So x equals 3, y equals 2, z equals 1, and w equals 0. And I had to do very little work, which really, really helps. So that RREF helps a lot. So let's talk about these dependent inconsistent systems and what happens. So if one of the rows of your reduced row echelon form has all zeros on the coefficient side and a non-zero number over here, then you have an inconsistent system because you're trying to say that 0 equals something else and it doesn't. If you have 0, 0, 0 on the coefficient side and you have another 0 over here, that means you have infinitely many solutions. You have a dependent system, and you must, again, give the general solution. That's very, very important. So let's look at some of these. So I'm going to do these again on your calculator because I want to practice and I want to show you what your calculator looks like when it does these. 2, -1, 1, 6, 3, 1, -1, 2, -1, 3, -3, 8. Okay, so let's look at your calculator and let's edit matrix B. Make this a 3 by 4 now. Okay, so again, I'm going to pause to put these in. Okay, once that is in, let's quit out of there. I'm going to go to matrix math, and I'm going to go, I know where it is now, so I'm going to go alpha apps for B, RF, and I want matrix B is the one that I put that one into. Now you see what happened. We ended up with the row reduced form gave us 1, -2, 0, 6, 0, 0, 1, 0, and 0, 0, 0, 0. So looking at this, what would you think? You end up with 0, 0, 0, 0. So you know that you don't know what Z is, but look at this. Do I know what Z is, actually? I do know what Z is. I know that Z is 0. I do have one solution. However, X and Y seem to depend on each other because look at this one. So if I go X minus 2Y, I'm going to rewrite this as is 6. So I know that Z has to be 0, but I know that X has to be 2Y plus 6. So I actually have a dependent system, even though I do have one solution, with the following. So we can call y to be some a, and I would have x equals 2a plus 6, y equals some a, any number, and z equals 0. And that's what would happen. So as long as z equals 0, it's this line right here is where the solution set is. So let's look at this next one. Let's put these ones in. So I'm going to go let's set up matrix C this time. I'm going to edit matrix C as a 3 by 4. Okay, I'm going to put these in while I pause. Okay, all in, matrix C. So I'm going to quit out of this, go back to matrix math. I'm going to go alpha apps, which brings up my B, and I'm going to go matrix C, number 3, and let's see what I get. 1, 0, 0, 0, 0, 1, -1, 0, 0, 0, 0, 1. Now this thing is trying to tell me that 0 z's equal 1. No. Actually, right, no. Because 0 can't be equal to 1. Therefore, this one is an inconsistent system. And there's nothing more that I can do. So I wanted to point these out especially because see the difference between having a 1 here and a 0 here. This just means that z is 0. This over here means 0 z's is 1. But 0 times any number has to be 0. So you can't do it. So that's the difference between these two. Okay, so that is it. And we will work on some more of these and different ways to do these.